Intensity. A wave transports energy as the wave propagates. If the wave carries energy densely packed together, then the wave is said to be a high-intensity wave. But as the wave propagates, the energy gets spread out over a larger and larger area. This causes the wave intensity to decrease. The symbol for intensity is I, capital I. The units are watts per square meter. Remember that watts are a measure of power, and power tells us how much energy is transported every second. So intensity tells us how much energy is transported by the wave every second through every square meter that the wave covers. As the wave spreads out, the area the energy is spread over increases, which will decrease the wave's intensity. As the wave spreads out, intensity decreases according to the inverse square law. Let's say you're standing a distance, capital D, from the speaker emitting a sound, and you hear intensity, capital I. Here's how the inverse square law works. If you move to a distance of 2D, the intensity will be 1/4 of that. It's the same thing as Newton's universal law of gravitation. It's the same thing as Coulomb's law for electrostatics. If you move to a distance of 3D, intensity becomes 1/9. If you move to a distance 1/4, then the intensity becomes 16 times I. If you move to a distance at 1/10 of what it initially was, then the intensity will become 100 times the intensity. So you get closer to the speaker and it gets a lot louder. If you get farther away, it gets quieter. Both of those happen quickly. If the distance is multiplied by n, then the intensity is multiplied by 1 over n squared.